Alright, in this video I'm going to go over the homework for 7.5, which is covering exponential functions. So this looks a lot like the skills practice that we did earlier. So in this top part, we're trying to determine whether the set of data shown displays exponential behavior or not, and then we want to explain why. So the first thing that we're going to do here is we're going to look for a constant rate of change with the x value. So if I'm looking at number 1, it's going -1, 0, 1, 2, 3. So this seems to be following a pattern of +1, +1, +1, and +1. So yes, this has a constant increase, which is what we're looking for. Then we want to pay close attention to what's happening with our y values. Since the x values are increasing at a constant rate, we want to see what kind of relationship there is with these y values. So with these y values, it's actually staying exactly the same. So as x is increasing, y is not changing at all. So you could describe this in a couple ways. You could say +0, or we could say -1. But so if we're using this idea that if we have a constant increase or decrease, it's linear, or if we have a constant common factor, that it's exponential, you could actually add or multiply to get 3, 3, 3, 3. But we want to think about what this would look like. So if I were to just graph this, and imagine what these points would look like on a graph if I'm at, here's -1, 0, 1, 2, 3. So at -1, 3, I'm right here. And at 0, 3, 1, 3, 2, 3, 3, 3, what we're creating is a straight horizontal line. So this data actually is linear. And I don't know why I wrote +1 down there. That's not correct. I meant +0 times 1. We could do times 1, or we could do +0. So we'll think of this as +0, 0, 0, 0. So no, this is not exponential. It's linear. The data form a straight horizontal line. So sometimes you just kind of have to think about it, what it would look like on a graph. So looking at number 2, we once again want to check our x values first. So I've got 4, 8, 12, 16. So from 4 to 8, if I'm adding, I'm doing a +4. From 8 to 12 is a +4, and from 12 to 16 is a +4. So our x values are increasing at a constant rate of 4, which is what I want. So now I want to look for a pattern in my y values. So I've got 20, 40, 80, 160. So you might think, okay, to get from 20 to 40, I'm doing +20. To get from 40 to 80, I'm actually not doing +20. 40 plus 20 is 60, and then if I look from 80 to 160, that's definitely not a +20. So this idea of +20 is not going to work. So could I get from one to the other by multiplication? Well, 20 times 2 is 40, and 40 times 2 is 80, and 80 times 2 is 160. So yes, this works, and each time what we're doing is we're multiplying, so we have a common factor. So yes, this is exponential. And we know because as the x values increase by 4, the y values have a common factor of 2, because we're multiplying by 2 each time. So it's getting bigger and bigger, so this looks like exponential growth. It's going up, up, up. So finally, let's take a look at number 3. We're going to start with the x values. I've got -3, -2, -1, 0. So it looks like we're following a pattern of +1 each time. So that is a constant increase. So I want to look at a pattern in my y's. And I have 9, 12, 15, 18. To get from 9 to 12, that's a +3. I can't really multiply 9 by anything to get to 12, and so let's see, 12, 13, 14, 15, that's another +3, and another +3. So this definitely looks linear because I have a constant rate of change. So no, it's not exponential, it's linear, because it has a constant rate of change, which is a slope, and you could say m equals, it would be y over x. 3 over 1 is 3. So this is going to be a line going up kind of steeply like this. So that's how we determine if data are linear or exponential. So now we're going to graph some of these functions. So if I'm looking at number 4, I've got y equals 2 raised to the x power. So I'm going to start by just picking my x values. I'm going to pick -2, -1, 0, 1, and 2. And I'm going to plug those in for x. So when I plug those in, I'm going to get y equals 2 to the -2. So remember, I can kind of use my calculator here. Let me find it. And I'm sorry if it's sideways, but 2 to the -2 means that it's going to be sent to the denominator. And so I'm going to get 0.25. And I'll go ahead and keep this as a decimal so it makes it easier to graph. So this equals 0.25. That's 1/4. So then I have 2 to the -1. Well, that's just going to send the 2 to the bottom, so I'm going to get 1/2, or 0.5. Then I have 2 to the 0, which anything to the 0 is 1. 2 to the 1, anything raised to the 1 is itself. And then I have 2 squared, which is 2 times itself, which equals 4. So now I'm ready to graph these points, starting with the point -2, 0.25. So if I go down 2, I'm going to go up 1/4, or up 0.25. That's going to put me just barely up right here. And then if I go to the point -1, 0.5, -1, 0.5, I'm going to go halfway up. And then I have 0, 1. So at 0, I'm going to go up 1. And then 1, 2. 1, 2 puts me here. And 2, 4. So over 2, 1, 2, 3, 4. So we can see this curve forming. It is starting low and it's going up high. So this is exponential growth. It's going up, it's increasing. Domain, remember domain are the x values. So x can really be anything I want it to be. I could plug in any negative number and I could plug in any big positive number. So the domain is all real numbers. As far as the range are y values. So remember, you've got to be careful here because we usually have a horizontal asymptote when we're dealing with exponential functions. So it looks like this one, we're not adding anything here. We saw on skills that if we're adding something, that's usually our asymptote. But here, it looks like we're going all the way down really close to this y equals 0, but it's never going to touch that. Because even if we do 2 to the negative, 2 to the -150, we're still going to have just like, it'll be a teeny tiny decimal, but it's still never going to hit 0, because you can keep cutting things in half or taking smaller parts of them, and you'll still end up with something, no matter how microscopic it might be. So our range here is y must be greater than 0. And our y-intercept, that's where we cross the y-axis, is right here at the point 0, 1. So that's my y-intercept. And my asymptote is this line right here, which is y, it's a horizontal line, y equals 0. So that answers all the questions for number 4. So now I'm going to take a look at number 5. Here we have y equals 1/3 raised to the x power. So I'm going to plug in points -2, -1, 0, 1, and 2. And I'm taking 1/3 and I'm raising that to -2. Remember to use parentheses when you're dealing with fractions. So I'm going to use my parentheses when I have 1/3 to the -2. So parentheses 1 divided by 3 raised to the -2, and I get 9. This equals 9. Now the reason that might kind of go against what you're thinking, if we have a fraction, we're raising it to a negative, but what a negative exponent means is we're like flipping the top and bottom, so we end up with a 3 squared on top, which is 9. That's the reason that happens. Then we have 1/3 to the -2, or 1/3, sorry, to the -1. And using that idea that a negative exponent flips, that means I'm going to have 3 to the 1, so this should equal 3. You can plug that in your calculator to verify that though. Then I have 1/3 raised to the 0. Anything to the 0 is 1. And then I have 1/3 to the first power, which is 1/3. And then I have 1/3 squared. So I square the top and I get 1. And 3 squared on bottom is 9. So now I'm ready to plot these points. You should notice too that these data are getting smaller and smaller and smaller. So I should expect my graph to go down. So my first point is -2, 9. So I'm going to go -2 and then up 1, 2, 3, 4, 5, 6, 7, 8, 9. That's all the way up here. And then I have the point -1, 3. So -1, 1, 2, 3. That's a significant decrease right there. Then I have the point 0, 1. So at 0, 1. And then I have the point 1, 1/3. So at 1, I'm going to go up 1/3 of the way. And then I have 2, 1/9. So that is going to be just barely above. So we can see that this comes down really, really fast, and then it levels off. And as you may have guessed, yes, this is going to get forever closer and closer and closer to this line, the x-axis, but it's never going to actually touch that line. It's an asymptote. So you can keep making these numbers smaller and smaller, and it'll get really, really close, but it'll never pass or cross through that line. So now we can answer the questions. Is this growth or decay? This is decay because it's going down. The domain, which are the x values, well, x can be anything we want it to be, so all real numbers. The range, which are the y values, we've got to be careful. This equation or this function starts up really high. It goes up to infinity, but as it comes down, it levels off at 0. So once again, y has to be greater than 0. The y-intercept, that is where this graph crosses the axis. It crosses at 0, 1. And the asymptote, that is this imaginary line that this graph is never going to touch or cross. That's the line y equals 0. All right, so we've got one more to go. This one's a little bit more complex, and so we want to be careful with our order of operations here. But we're going to start off just the same way. We're going to plug in points -2, -1, 0, 1, and 2. I'm trying to give myself some space to solve here. So when I plug in the point -2, I need to plug in this whole thing. So I've got y equals 2 times 2 to the -2 minus 1, and I'm going to solve. So remember order of operations. I need to do everything in the parentheses first. Whoops, that's really big. I need to do everything inside of this parentheses first, and then the last thing I'm going to do is multiply by 2. So I'm going to do 2 to the -2, subtract 1, and then multiply by 2. That's my order of operations, and it's important that you follow that order. So 2 to the -2, I'm going to clear. So 2 to the -2 equals, and then I need to do -1 because that was in the parentheses, equals, and then the last thing I'm going to do is multiply by 2, equals, and I get -1.5. So -1.5. Also, it's important that you're kind of like writing down. I like you to show me how you're plugging things in, even if there's not a ton of space. If you're doing this on your own paper, you can give yourself more space. If you're using my note paper, try and squeeze it in like this so that I can see exactly how you're plugging it in. Don't just like write down the y value if you can help it. So then we're going to solve y equals 2 times 2 to the -1 minus 1. So 2 to the -1 first, then I'm going to do -1, then I'm going to do times 2 last because that's on the outside of the parentheses. So going back to my calculator, I'm going to clear this. I have 2 to the -1, and then I'm going to, what am I doing? I forgot. -1 and then times 2. So 0.5 minus 1 equals, and then times 2 equals, and I get -1. Equals -1. So now I'm going to plug in 0, so I get y equals 2 times 2 to the 0 minus 1. This one I can probably just solve on my own, because I know anything raised to the 0 is 1, so 2 to the 0 is 1, 1 minus 1 is 0, and then 0 times 2 is 0, so this will be 0. Then I have y equals 2 times 2 to the 1 minus 1. Well, 2 to the 1 is 2, 2 minus 1 is 1, and 1 times 2 is 2. And then I have y equals 2 times 2 squared minus 1. So 2 squared is 4, 4 minus 1 is 3, 3 times 2 is 6. So now I can start to plot these points. My first point is -2, comma, -1.5. So I'm going to go over 2, and then down 1.5. So that puts me here. This is our first time, I think, going below the x-axis. Our next point is -1, comma, -1. So at -1, I'm going to go down 1. My next point is 0, 0, right here. My next point is 1, comma, 2. 1, comma, 2. And my last point is 2, comma, 6. So 2, comma, 1, 2, 3, 4, 5, 6. So we can see that this is curving up, and then it's leveling off like this. So it appears that this one's a little unique because we are definitely going below that line, y equals 0. We're definitely down below that. And it looks like, though, my graph is leveling off here. This is my asymptote. And I can know that because actually, if I were to distribute this through, as we saw up in like the skills practice, usually this number over here, plus or minus something at the end, tells us what our asymptote is. So in this one, we shifted up 1. In this one, we also shifted up 1. Down here, I know it's kind of hard to see because it's in parentheses, but if we were to distribute this through, what would we end up with over here? Well, 2 times -1 is a -2. So it makes sense that our graph is shifted down 2, like this. So we do have an asymptote here on this line. And that's always a way you can kind of think about it, if that makes sense to you, is this like point right here. So to answer these questions, our graph is going up, so we have exponential growth. The domain, which are the x values, once again, is all real numbers. We can let x be anything we want it to be. The range, which are the y values, we can't have everything. It's going to go up and up and up forever, but as it comes down, or where it starts off, we're never going to start off below this line right here. That's not going to happen. So y values have to be greater than -2. And once again, you can look at this. We distribute this through. We get a value that tells us what our asymptote is. And then our y-intercept, that's where we cross the y-axis. That's happening right at the origin at 0, 0 for this graph. And then our asymptote is this line right here. And that's a horizontal line, hoi, which is y equals -2. All right, so that is it for our homework. If you have any further questions on this page or